All right, we're back. We're on page 8 of Notes 21, Calc AB. We've been doing like a lot of volume type problems. Now we're going to do kind of a mixed review type thing. So we got a couple regions, R1, we got R2, which is this tiny thing. We're given their intersection points, which is awesome. We're told f of x is a trig thing, so it's 2 minus 2 sines. So that's going to be this, I guess. And then g of x is a quadratic that opens down. So that's going to be this. All right. Write an equation for the line tangent to the graph of f at x equals 1. So I need to know f of 1, which is 2 minus 2 sine of pi over 4. Sine of pi over 4 is root 2 over 2. So 2 times that is just root 2. F prime is going to be the derivative. So the derivative of sine of pi over 4x is pi over 4 cosine of pi over 4x, but then times negative 2. So negative pi over 2 cosine of pi over 4x. I want to think about that again. So it's negative 2 times pi over 4 is negative pi over 2 times cosine of pi. Yes, okay. And then f prime of 1 is negative pi over 2 cosine of pi over 4, which is also root 2 over 2. So negative pi root 2 over 4. Crazy. You get crazy. Like, don't expect your tangent lines to look nice. Don't expect your tangent lines to be useful, really, is what it like comes down to. Because like, what's a human going to do with this tangent line? I don't know, but we got it. So it's going to be y minus the quantity 2 minus root 2 equals negative pi root 2 over 4, quantity x minus 1. There you go. All right. Find the area of R1. So R1 is, so let's do, I'm going to highlight for like top and bottom. So this is the trig thing, and the trig thing is going to be the bottom function on the interval. And then this is the quadratic. The quadratic is going to be the top function on the interval. There we go. All right, so we're going to do the integral of top takeaway bottom from 0 to 6. Integral top takeaway bottom from 0 to 6. So I'm going to write it while I can see it. Integral 0 to 6. Top curve is the quadratic thing, which is like a very weird quadratic. I mean, I think it's to make the intersection points nice. But, you know, you get all types of things. And then dx. All right, let's like clean this up. So this is the integral from 0 to 6 of 14 minus 2 is 8/3. There's not a lot of cleaning to be done, but, you know, it makes life a little bit easier. I don't even know if that's true. Okay. Integrate. I get 8x. What? 8x over 3. 8/3 x minus quantity x minus 4 cubed over 3 times 6 is 18 plus, no, minus 8 over pi cosine pi over 4x. Feel free to go back and do u substitution on any part of this that you feel it's necessary. I think if you do enough problems, eventually you can kind of like get through these without that. All right, if I plug in 6, I get 6 over 3 is 2, so 16 minus 6 minus 4 is 2, cubed is 8. 8 over 18 is 4 over 9. Cosine of 3 pi over 2 is 0, so that just disappears. Minus quantity. Plug in 0. 8/3 times 0 is 0. Minus negative 4 cubed is negative 64. So that's really plus 64 over 18, which is plus 32 over 9. And then the cosine of 0 is 1, so minus 8 over pi. Okay, so this is 16 plus 28 over 9. 16 plus 28 over 9. what is 60? So 144 plus 28 over 9. What is that? 160, 172 over 9, which is not divisible. So I don't know. Is that it? Should I check on a calculator? I feel like that's probably not right, but why do I feel that way? 64. So 0, negative 4 cubed is negative 64. Negative 64 is positive 64. 64 over 18 is definitely 32 over 9. And then minus, oh wait, what? That's wrong. Hold on. We're wrong, everybody. We're wrong in my brain, basically. So it's actually 16 minus 36 over 9. 16 minus 4. 16 minus 4 is 12. 12 plus 8 over pi. I feel like that is the answer. How much is left here? Two things? All right, well, this one says to use a calculator, so, you know. Write an integral expression for the volume of the solid generated when R2 is rotated about the line y equals 1. Y equals 1. Y equals 1 is down here. Okay, so we're going around that. We're going to have a big, so the question is like, what's on top, what's on bottom? On top is this thing, and on bottom, it's like really hard to highlight these. On bottom is that. All right, so we need a big R. Oh, I guess we're using a dotted line. It's because in one of my classes, we're doing trig graphs. So a lot of dotted lines, that's gonna be capital R. And then we need a little r. So big R is gonna be the blue thing. So f of x minus 1. And then little r is gonna be g of x minus 1. And then we're going from 6 to 8. All right, so maybe I'll just write it here and then take it with me. The integral from 6 to 8 of the quantity, big R, f of x minus 1 squared minus the quantity, little r, which is g of x minus 1 squared dx. Let's take that with us. Let's also fix this f, which just did not work out. F. All right, it's all coming with us. Here we go. Back down. So this should work. And we will use a calculator to get that. I mean, like, it's all about the setting up, because if you're just gonna use a calculator anyway, you know. And then there's a vertical line, x equals k. 0 is less than or equal to k is less than or equal to 6. It divides the region R1 in such a way. The area to the left of k is 3 times the area to the right of k. Write an equation, use a calculator to try to find the value. Okay, so there's a line. The area to the left is bigger. So let's put in a line. I don't know, maybe like here. Right? So the area to the left is bigger. So if I find the area to the left and the area to the right, I have to multiply the area to the right by 3 to make it equal the area to the left. Right? If this ends up like z, no, if this ends up z, then this would have to be 3z because it's 3 times as big. Or if this is z, what? It's 3 times as big. So now I'm multiplying the area. Oh yeah. So I have to multiply the area to the right by 3 to get the area to the left. Yes. All right, let's do that. Let's not have an or scenario here. Unnecessary. All right, so we're gonna do the integral. I don't even know what we're doing. Let's write it up here and we'll take it with us. We want to do the integral from 0 to k of g of x minus f of x. So this is why you name functions. Should be equal to 3 times the integral from k to 6 of g of x minus f of x. Seems weird because it's just doing all the work, but you know. Ooh. All right, bring this with us and then switch to calculator. find out what we did and did not get right. Well, some of it we won't know anyway, you know, because like if we're just using a calculator. All right, to the calculator. And then if you're confident that everything we did is right, which I would not be, but you know, you're done. You can get out of here. So I'm in radians. That's a big thing. Pi over 4x g of x is going to be 14/3 minus quantity x minus 4 to the second over 6. All right. So integral from 0 to 6 of, what do we do? Something minus something, g of x minus f of x, comma x from 0 to 6. 12 plus, yes, we got it. Oh, okay, so I definitely got the next one wrong because I forgot pi times the integral. So I'm gonna go back and fix that for sure. 6 to 8. That's the thing, you get like, so I get so fixated, I don't know about you, on like, oh, I'm just gonna use a calculator, that like my work gets a little sloppy, and that's where the points go. Tx. Okay, let's get an approximation. 4.737. 4.737, and I'm gonna put in a pi, and I will highlight that because I forgot it. That's it. You gotta like, not necessarily punish yourself, but you know. All right, let's see. The integral, so I want to solve an equation, menu 3, enter, and the equation is going to be from 0 to k of g of x minus f of x with respect to x is the same as 3 times the integral from k to 6 of g of x minus f of x dx, and then we want to solve for k. And then technically k is between 0 and 6. Let's see. All right, so 3.568. K is approximately 3.568. Let's like check it and just make sure, right? So if I do this such that, let's copy and paste. It's not going to be exact because these are not exact answers. There, that should be 3 times what I get if I just do this. So such that, here we go. It's like, why not? Why not check? There, if I multiply this by 3, I get yes. All right, it worked. Nice. All right, so go back to the notes. I'll show you where I forgot to write in pi, and so that is shameful, but I fixed it. So up here on part something, C, part C, I forgot to put in pi. Terrible. That's like literally terrible. I should not have done that. Otherwise, this is a good free response type of question. I could imagine you being asked all of this. I guess it would have to be, part C would probably be set up but do not evaluate. Part D could be set up but do not evaluate. And then it could be all non-calculator, or it could be all calculator and you just get like, you know, you just blow through parts A and B. Either way, I'm gonna stop the video here. I'll be back in the next one, do some more. So I will see you there.